Yo, 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 what's up, everybody? It's your boy, Mr. Felton. You know what I'm saying? Y'all know what time it is. It's time to detox with some of that Redox. You know what I'm saying? Take out your worksheet, and for this, you'll also need a periodic table and the list of 5 rules that I gave you in class for redox reactions. Let's take a look at number 1. Number 1, we have strontium plus oxygen yields 2 strontium oxide. Now in my rules, balancing isn't really a big issue, but we could put the coefficients here anyway. Alright, so if I were to look at this in redox reactions, we're looking for a change in charge. In this case, according to my rules, strontium, which is just a element that's alone, will have a charge of 0 here. Oxygen, which is a diatom, has a charge of 0. And then this yields a product of strontium oxide, which is a ionic compound. By using my periodic table and what I learned thus far in Mr. Felton's amazing chemistry class, we would know that any of the elements that fall in group 16, if they're in an ionic compound, they have a charge of -2. And if they're in group 2, like strontium is, it will have a +2 charge. Fantastic. So, when looking at this, strontium went from having a charge of 0 to +2. And oxygen had a charge of 0 and went to -2. Fantastic. So now, if we have strontium losing electrons, it becomes positive. So if it's becoming positive, that means that it is oxidized. And here oxygen is gaining electrons or becoming more negative, so it is being reduced. Alright. Now something that I only taught 10A and grade 11 is that if you have something that's being oxidized, like in this case strontium, well, who's oxidizing it? In this case it's oxygen. So oxygen is the oxidizing agent. I'm going to abbreviate it as ox agent. And if oxygen is being reduced, who's reducing it? In this case, it's strontium. So strontium is the reducing agent. So all my fans and subscribers in 10B, this will be new to you, but you can learn it through this video, no problem. So this is my answer, my complete answer for 1A. Or number one. Alright, number 2. Because you know how we do. I'm staying up late making a video for you. No, seriously, I made a video and for whatever reason, the file didn't work. So this is video 2 that I'm making for you. Alright, number 2. We have lithium plus sulfur gives me lithium sulfide. Alright, lithium here has a charge of 0. Sulfur has 0 because they're alone. Lithium, we'll take a look at after we look at sulfur. Sulfur is in group 16. Alright, it only needs 2 electrons to become full. So when it's going to get those electrons from lithium, so it will be -2, have a -2 charge. Lithium is in group 1. That means that each one has a +1 charge. Lithium has a +1 charge. I have 2 of them though. So that means the total charge on lithium is +2. But if you were to have a question is what is the oxidation number of lithium, it's +1. So lithium went from 0 to +1. sulfur went from 0 to -2. So lithium was oxidized. And because it was oxidized, you'll notice that, just like in question 1, it's the opposite as far as what type of agent it is. So if it's oxidized, that means it's the reducing agent. And who does it reduce? In this case, sulfur, because sulfur is reduced. Since sulfur is reduced, it was reduced by lithium, right? And sulfur is the oxidizing agent that oxidized lithium. All right, that is number 2. Number 3, because you know how we be, is CS plus Br. 2 gives me 2CsBr. Fantastic. Cesium here is alone, so it has a 0 charge. Bromine is a diatom, so in this case it also has a 0 charge. In this ionic compound, where cesium is the metal, bromine is the nonmetal, you can use your periodic table for this, and you will get a -1 charge and +1 charge by viewing those. So CS went from 0 to +1. Bromine went from 0 to -1. So cesium, as you probably guessed correctly, was oxidized. Bromine was reduced. Who reduced bromine? Cesium. So that means cesium is the reducing agent. And who oxidized cesium? Bromine. So that makes bromine the oxidizing agent. That was number 3. Moving on to number 4. Something also, a little side note to make sure you memorize and keep in mind, is that little guide I gave you guys, the little charts where it's like this, the charge thing. This will help you a lot, so that when you grow up and you're teaching your kids redox reactions and remembering chemistry class, make sure you teach them this. They'll really appreciate it. I know I sure did. Number 4, we have magnesium plus nitrogen gives me Mg3 and 2. Cool. In this case, magnesium is 0. Nitrogen is a diatom, it's 0. I have 3 magnesium here. I have 3 of them. Okay, so if I have 3 magnesium and I look at my periodic table, it's in group 2, which means that it will have, each magnesium will have 2 valence electrons it wants to get rid of, right? When it gets rid of them, it has a +2 charge. So I have 3 magnesium getting a +2 charge. I have 3 of them. So the total charge here is +6. Well, nitrogen, which I have 2 of, has to take out that +6 with something, which in this case will be a -6, to have magnesium nitride without any charge. I have 2 of them here, so -6 divided by 2 is -3. Mg, magnesium, went from 0 to the oxidation number of +2. Don't make the mistake of saying +6. The total of magnesium is +6, not magnesium itself. Nitrogen went from 0 to -3. Magnesium lost electrons and became more positive, so it was oxidized. Oxidized. And nitrogen was reduced. By now we should know that if something is oxidized, it must be the reducing agent. And if something's reduced, that means it's the oxidizing agent. Fantastic. So where would this chart have helped you? If I started with at nitrogen, if I look at nitrogen, we start at 0, and it went down 1, 2, 3. Usually when we think of the term to be reduced, it means to be cut down or to go down. So this chart kind of helps you out with that. But in actuality, it's gaining something. It's gaining electrons. So be careful with that. You know what I'm saying? If you're interested or have any comments, please make sure to like this video and subscribe and comment below on any ideas you might have. All right, number 5. We have 4Fe plus oxygen, and we have 3 of those. That's going to yield Fe2O3. Although this is balanced, I have 2 of these. Although these are balanced, one of my rules for redox reactions is I don't care about balancing, so the coefficients are not that important. So let's look at this. Here iron is alone, so it has a charge of 0. This diatom oxygen is 0. When we look at these, oxygen is always -2. Alright, I have 3 oxygens, so that means the total charge for oxygen is -6. Alright. So, iron, in order for this compound here to have no charge, iron has to cancel out this -6 with a +6. So what charge or oxidation number does iron have to have? +3. I have 2 of them. So each one, if I have 2 +3 irons, then that means they total to +6. So iron went from 0 to +3. Oxygen went from 0 to -2. Iron was oxidized. Oxygen was reduced. Iron is the reducing agent, and oxygen is the oxidizing agent. And that was number 5. If you're still alive watching this video, I hope you are. Because if you're not, I'll miss you. And you'll miss me, probably. But if not, that's okay. Number 6. Now we have a different type of reaction. 1 through 5, I can clearly look at them and see those are synthesis reactions. When I look at number 5, or 6, when I look at number 6, it looks a little bit different. It looks more like a single replacement reaction. That's because it is. We start out with a diatom of chlorine plus sodium bromide, and that's going to yield sodium chloride, also known as table salt, the stuff you put on your food, plus bromine as a diatom. You might notice I didn't put the coefficients or balance because it's not necessary. Chlorine here has a charge of 0. This is an ionic compound, so be careful. Sodium will have a +1 charge. Bromine has a -1 charge. When I look at my products, sodium has a +1 charge, Chlorine has a -1 charge. Bromine now has 0 as it is a diatom. Alright, so chlorine went from 0 to -1. Sodium went from +1 to +1. Oh boy. And bromine went from -1 to 0. Alright, let's look at this. Chlorine went down in charge. It gained an electron, but it went, according to our chart, it went down, so it was reduced. Sodium, nothing happened. Finally, bromine went from -1 to 0, which is going in an upward direction according to our chart. So in this case, it lost an electron. When I lose electrons, I become more positive. So this is oxidized. If this is oxidized, it means it's my reducing agent. And chlorine was reduced, so it means it's my oxidizing agent. Number 7, we have silicon plus fluorine yields silicon tetrafluoride, I believe would be the name of this. Unless you consider silicon as a metal. And in that case, it would just be silicon fluoride. But we might get into that later. Alright. This is going to be a very interesting problem or question because I believe it was Noor in 10B. One time she asked the question about carbon. Does carbon have a +4 charge? Well, you'll see in that column, or in that group, where carbon is the carbon family, that indeed it can have a +4 charge, just like silicon in this case can. So in this case here we have silicon is 0, fluorine is 0. If I were to pretend I don't know what silicon is, fine. But I know that fluorine has an oxidation number of -1. And I have 4 of them, so that means the total for fluorine is -4. What does silicon have to be in order to get rid of that? It has to be +4. So silicon went from 0 to +4, and fluorine went from 0 to -1. This was oxidized, this was reduced. If this was oxidized, it means it's my reducing agent. And if this was reduced, it means it's my oxidizing agent. If you were asked, what is the oxidation number of silicon? You'd say +4. Or +4. What is the oxidation number of fluorine? -1. So be careful with that. Almost done here. Moving on to number 8. Staying up late in Kuwait. I'm doing some steps while I'm working here. Okay, number 8. We have calcium plus oxygen yields calcium oxide. This is a very simple synthesis reaction. Calcium has a charge of 0. This diatom of oxygen has 0. Calcium is in the second group on the periodic table, so I know it's -2. Oxygen, we're very familiar with it by now. I apologize, it's -2. okay? It's in group 16. It needs 2 electrons. So if it made an ionic compound like here, it would gain 2 electrons, giving it a -2 charge. So Ca went from 0 to +2. Oxygen went from 0 to -2. Calcium was oxidized. Oxygen was reduced. Calcium is my reducing agent. And oxygen is my oxidizing agent. It's a pretty straightforward, simple problem. And I just dropped my mug, but that's okay. Sound effects are good during a video. It lets you know that things are happening. Because you can't see me right now. You can only see me right. But how do you know that this is real? You gotta have these kind of sound effects. You know what I'm saying? Alright, number 9. We have magnesium plus HCl. It's going to yield MgCl2 plus H2. Magnesium here is 0. Alright. Now I have HCl, hydrochloric acid. In this case, all acids are going to be ionic compounds. And from our naming, when we learned naming, if I have hydrogen as a cation, it's an acid. Cool. +1 charge. You can look at the periodic table. It's in group 1. Chlorine is in group 17. It has a -1 charge. Make that look nicer. Just for you. Cool. Now if I go to my products, I have 2 chlorine, but each one will have a -1 charge. So the oxidation number for chlorine is -1. Because I had 2 of them, the total is -2. Magnesium, I only have 1 of them. It's in group 2, so that has a +2 charge over here. And now hydrogen is a diatom, so it has a charge of 0. Mg went from 0 to +2. Chlorine went from -1 to -1, not -2. Hydrogen went from +1 to 0. So in this case, magnesium was oxidized. Automatically, I can tell you that it's the reducing agent. Chlorine, nothing happened to it. And finally, hydrogen. It went from +1 to 0. That means it went down. It was reduced. And therefore, it is my oxidizing agent. I didn't know I can move that. That's pretty cool. It's my oxidizing agent. All right, fellow chemists. Last one. You can view this as many times as you want. You could like it as many times as you want. You could subscribe as many times as you want. You could share it as many times as you want. Whatever you want to do. Just feel free. That's the most important part. That's what chemistry is all about. Okay, number 10. I have sodium plus water, H2O, more formally known as dihydrogen monoxide, but I prefer water. That's going to yield NaOH plus H2. I really like this problem because it emphasizes one of the rules that we had with water, and that I split it up right in the beginning to H plus and OH minus. Now, if I have these as my reactants, it looks more like a single replacement reaction, and that's how it behaves. Alright? So here, sodium has a charge of 0. When I look at my products, I can see automatically I have hydroxide and sodium. Hydroxide I know has a -1 charge. Therefore, sodium has to have +1, or you can look at a periodic table, it's in group 1. And hydrogen here is a diatom, so it's 0. Sodium went from 0 to +1. Hydrogen went from +1 to 0. And hydroxide, that ion went from -1 to -1. Alright. So sodium was oxidized. Hydrogen went from +1 to 0, it was reduced. Hydroxide, nothing. Who reduced hydrogen? Sodium, so sodium's my reducing agent. And who reduced my hydrogen? Sodium. Wait, did I get that right? Am I saying this correctly? Yeah, who reduced my hydrogen? Sodium. So it's the reducing agent. And who reduced my hydrogen? The sodium. Which was oxidized. And who oxidized it? The hydrogen. So the hydrogen's the oxidizing agent. .007. Please, in the comments below, just maybe mention what colors you like. If you'd rather have like red or blue or black or yellow. You know, it's kids like colors. It makes them happy, and sometimes helps them memorize what's going on in class. Okay. If you have any questions, please visit me, and until next time.